Hello everyone to our next session where the company Leaseweb will present their CloudStack user story and how they're migrating live virtual machines to new data centers. We have Neven and Sina from their team. Please share a few words about yourself and let's give them a warm welcome.
Thank you, Iveta. And thanks guys for joining our session. We will present a little bit our experience about our use of CloudStack and how we used some of our own tools to migrate virtual machines between two data centers. Yeah, a little bit about myself. I'm Neven, product owner at Leaseweb. And yeah, together with a team of DevOps engineers, we are responsible of operating and developing our CloudStack platforms. And together with me is sitting Sina. He will also present his part. So Sina.
Thanks, Nevin. My name is Sina. I'm a software engineer at Leaseweb. I joined their team right before the Corona. Some words about me. I enjoyed connecting stuff together since I was a little boy. And that's why I love computer network. And I work with Java to implement the stuff and connect things together. While I'm not writing a code, I'm probably cooking or playing with my models or electronic devices. And that's basically me. Back to you, Nevin.
Yes, thanks. So just a little bit about Leaseweb before we continue. Leaseweb is as an infrastructure as a service hosting provider, running CloudStack platforms on global scale in different continents. We are active in Europe, the United States, and also in Asia. We run CloudStack for different type of services. So we provide CloudStack, or we use CloudStack to provide virtual private servers to customers, and that is just single VMs with a public IP address that is also integrated into our own customer portal. But besides that, we also have private cloud with the resource pools that we provide to customers, and we provide those type of customers direct access to the CloudStack dashboard. So they also experience the old UI and the new UI, which is provided a lot of good feedback. And besides that, we have also our Leaseweb internal cloud, basically our own websites, applications, and services that run also on CloudStack. So we are a proud CloudStack user in that sense. And go to the next. Yeah. So coming back then to the scope of this initiative that we have, as I mentioned, our main objective is to migrate VMs from one data center to another data center, actually migrating the entire infrastructure because we were at the time switching from data centers. So we had three main targets in mind. And the first one being, of course, we needed to move our entire stack, including all the hardware, all the VMs from customers, customer data, everything. And secondly, of course, what was really important is there must be no customer downtime. So we needed to do this somehow online without going offline to prevent that customers being impacted. And the third main target was to reuse hardware as much as possible. This would prevent us from doing any high investments that would be redundant afterwards, since we needed to rebuy the whole hardware that we have running already.
So, and now I'm presenting to you how we did that. I'm starting with a small example that we have two data center, one in the left and one in the right. I call them DC1 and DC2 for simplicity. And they are connected with wave connection. It's around 40 gigabit bandwidths. Our ultimate goal is to migrate VM from DC1 data center to DC2 data center without downtime. Let's focus on components on DC1. We have blue pentagons, yellow disks, and red management nodes there. Pentagons represent VM processing units like CPU and RAM. Disks are the volume hardware of the VMs. Each VM has one pentagon and at least one volume. As you can see on the left rack, this VM, VM7 has 2 volumes, but VM6 has 1. We wanted, so our ultimate goal is, again, moving all the pentagons, disks, and circles from DC1 to DC2. First thing first, we set up a new rack in DC2 and add it to our environment. So we have a really great connection between these two data centers. That would be, we can do that. And we migrate a processing unit from DC1 to this rack using CloudStack Migration Virtual Machine API call. That's an easy task, but volume migration isn't a simple task because CloudStack doesn't support it internally, and I will explain it in the upcoming slides why we can't do that and what are our challenges. Back to me.
Yeah, so just a little bit on why not the CloudStack API. So for us to use the CloudStack API, we needed to be on a certain version of CloudStack. At the time when we were into this project, we were using 4.7 as our core, basically, and on top of that, our own customization. So we had our own fork of CloudStack. So by default, the API wasn't available at all. So we needed to figure out how we should do it then. So one option was to see if we could backport the feature, because it was released, if I'm not mistaken, in 4.13, to backport it to our own fork and then use the CloudStack way to do the migrations. But during the assessment of that, we basically found out that it was quite a risky thing. There was quite some code changes that needed to be done, and after some testing of our own, we noticed that we just couldn't make it work in time. And besides that, there were some missing valuable functionality. Basically, what was really important for us, because we also had customers with really large VMs and really large volumes, that we could monitor the progression and also see in case of when it stalled or when there were some issues, that we could jump on it right away. So in the end, we decided to kind of bypass CloudStack and create our own tool, which would use Qemu and libvirt directly for the migrations, and that will also allow us to create some specific functionality for us to track also the migrations, and also do a good migration per node, and also per also all the volumes that were attached to that to those VMs of that node. So Sina will explain how we went on with that.
So we use QCO2 image format. It's a default and recommended Qemu image format, and it's used by CloudStack. So let's see what's inside the volume. So that contains template image and disk image. To move it from one side to another side, we need to move these images. But when VM writes data on volume, they are written on a disk image at the top. But they will not change anything on the template image because it's read-only and it's attached to the VM. So basically, we can copy template image from one location to new location, and it will not get corrupted. But when VM reads data from the disk, if it exists on a disk image, it will read that. But if it's not, it will try to read that file from the template image. So basically, we have to be worried about the disk image. It can get corrupted when we are moving the data, and we don't have to be worried about the template image at all. But what about a snapshot? What happens if VM has a snapshot? To deal with that, we have to see how a snapshot are created. When user click on create a snapshot button, new Qcode2 image is created. Fortunately, it's read-only, and we can treat that like a template image. For simplicity, we skip this part and we assume that our VM doesn't have any snapshot. We break our steps into 4. Our plan is to simply copy the template image to the new location. It's read-only. We can do that. We don't have to worry about its corruption. And we can do that even if VM is running. And then we use libvirt bulk copy command to move the disk image. It has some superpower to move data from one location to different location. I will explain that in the next slide. But there is one pointer that points from data disk to template image. We have to edit that carefully to the new location. So in case of something goes wrong, VM can recover from that template image. And finally, we can update the volumes storage pool ID in the CloudStack database. We have to hack into the CloudStack database and change it manually. So let's see how it works. There is a volume on the left storage pool that we want to move into the right one. We know that we can simply move the template image using the cp command because it's read-only and we can move it without any issue. Now it's time to move the disk image. Libvirt bulk copy command is used to move the data disk to the new storage. Bulk copy command has a superpower. If VM writes data on a disk while it's moving the disk image, they are written on both sides. As you can see, with this feature, we don't have to be worried about the data corruption, because if any change happened during the migration, they will be in both sides. Let's check our flow once again. We copied the template image to new location, and we also moved the data disk to new storage vault. It's time to change the pointer. We should do that in next slide. Disk image has a pointer that points to the backing file image. At this moment, they are both pointing to the same template image on the left. We can edit this pointer using the change backing file command provided by Qemu. You can see the sample command in the blue box. After this command execution, it will change the backing file pointer back to the template image, new template image in the storage too. So it's done. We move everything. We only need to change the CloudStack database, but it's easy task. I'm pretty sure everyone can do that. Let's skip that. So let's get back to our example. Remember that we have 2 data centers and we wanted to move VMs from one DC to from DC1 to DC2. We have already moved processing units. Now it's time for volume migration. We use our own script and move volumes to new location. Keep in mind that it does a lot of work in background, with bulk copy, template image migration, and other stuff. Now we can remove the empty rack in DC1. It's gone. And add new rack in DC2 for next round of migration. We used Elixir containers to deploy and manage management servers. We can switch them and move them to the new location without any problem. It's just easy task. And repeat the same procedure for the remaining VMs and move them to new location. Everything moved now. We can shut down the DC1. But something important, we talk to Qemu behind the libvirt, and we talk to libvirt behind the CloudStack. That's the really bad things, because we ignore some layer of abstraction. That's why we plan to, later we plan to switch to the community API call. But as mentioned by Evan, we have some problem because we can track progress and other stuff. We are figuring out what we can do to switch our changes to the community and make a good API call out of it. And that's it. And back to you, Nevin, for this, or for this one. So final words. If you want to follow the same procedure, remember to disable VM control during migration. Customers' intervention can interrupt the procedure. They can switch off, switch on, and do bad thing to the VM that you don't want to happen while moving the VM. Don't remove the original disk after migration. Keep them in a safe place. And if anything goes wrong, you can recover the image from the backing file. And this feature is not supported by CloudStack API. We can just move, create new clone in new volume and keep the original one in the archive folder. We need some bandwidth limits. 1 terabyte disk image can decrease your network quality. And that's it. Some of the edge cases didn't cover in this presentation due to the time limit. That's it. And thanks for joining. Yeah.
Thanks, Sina. And should we go to the questions?
Are you ready for the questions?
Yep.
Okay. Give me 1 second to check the Q&A tab. I will start first with some questions which we had earlier in the community and in the watch results. Why a company like Leaseweb, which is obviously a leading infrastructure as a service provider, decided to use an open source technology, and do you find it reliable in the long term?
I believe we as a global hosting provider, at the time we were using, I think we started using CloudStack in 2013 already, somewhere around that time. And I believe that, first of all, CloudStack was if I'm not mistaken, the first with such a tool that could provide this type of orchestration and building your own clouds. So yeah, we were assessing that, and we also have our own VMware offering. So they're kind of a little bit in a competing stage between each other. But we found that CloudStack is overall very reliable to us. With a key fact that we have been developing quite some custom stuff of our own, and for actually the last year or two almost already, we have been moving back to the community. We've provided a lot of our features back to the community, and we hope they also get. There's still a lot of them open. We hope that they get merged soon, so we can also reduce the gap to the community and keep using the community version.
So you're also actively contributing to the project.
Yeah, definitely. Yeah.
Awesome. Great to see more companies who are active in the community and who would like to contribute and help make CloudStack even better. Continuing with two more questions. What was the most nail-biting situation during migration, and was there any failures? If so, how did you handle them?
Failure.
Or maybe no failures at all. And
I believe we didn't really have big failures. There was one problem that we faced that with this process, we were limited to disks up to around 1 terabyte in size. If they were larger than that, that would time out the process. So there were some hiccups there, which we had to bypass somehow, because in some situations we had customers with really large volumes, up to like 4 or 5 terabytes. I believe that was only the thing. For the rest, it went quite smooth. We repeated the process in different times already. So pretty well.
Okay. Next question is why you didn't upgrade to 4.14 or 4.15 and then why migrate the VMs?
That's we have a lot of feature for ourselves, and as I mentioned earlier about Nevin, we keep our fork that has a huge deviation between our fork and community, like I think 1200 commits deviation. That took us 1.5 years to port all the stuff back to the community. And if we want to port everything to 4.14 and then start from that point, it took us at least 1 year. And we don't want to wait that time. We don't have that time.
Yeah, it would be really hard for you because I suppose you have also timelines and schedules which you need to chase. And in terms of the open source technology and the development of the CloudStack project, do you think that this is a competitive advantage for IaaS providers like you? And would you actually recommend CloudStack to other mid-sized or large-scale IaaS providers?
Yeah, I believe so. I've been talking to different type of customers all over the world that were looking to switch from on-premise to cloud solutions, and they were also asking us what our experience was in terms of performance, in terms of usage, and we find the using CloudStack it's really easy and it works. But we have been seeing also stuff not working, but it was really easy for us to make changes, and that was also the beginning how we started our own fork. But I believe that if we work closely with the community on making releases really reliable also, that we can prevent those, and then because it's so easy to use, it's a really good solution.
And its killer feature is maintenance. You can manage it CloudStack environment with, I think, at least 3 or 5 people, but it's not the case with other competitor.
So really easy even in large-scale environments.
Yeah.
Thank you very much, Nevin and Sina. It was a pleasure to have you here as speakers at the CloudStack Collaboration Conference, and we really hope to see you live on our next live events.
Yes. Thanks.
Yes. I'm looking forward to that.
Looking forward. Yeah. See you there.
Thanks. Have a nice day. Yes.
Bye.
Bye-bye.